Okay, so first of all, I'd like to thank all of you for the invitation. I would also like to point out that the group on called Science and Faith on the Interpretation of Reality is no longer formally affiliated with Lateran University. It's now an independent institution, but the spirit hasn't changed. And I will follow the slides, perhaps adding here and there some statement. So many scholars consider Galileo Galilei the father of modern science. Galileo Galilei was born in Pisa in 1564 and died in Tuscany in 1642. And I reported here a famous statement. I think that in discussions of physical problems, we ought to begin not from the authority of scriptural passages, but from sense experiences and necessary demonstrations. And this coupled, sense experiences and necessary demonstration, is often considered as a description of what modern science is all about. The statement is taken from a letter that Galileo addressed to the Grand Duchess of Tuscany, Madame Christine de Lorraine, precisely in order to explain his point of view about science and also explain his point of view about the relationship between science and the church authority. So it's true that the key point for modern science is in the words sense experiences and necessary demonstrations, but this entire letter in fact aims to defend scientific investigation from undue religious interference. And in fact, shortly after the passage quoted above, you can read the following words. It appears that nothing physical which sense experience sets before our eyes, or which necessary demonstrations prove to us, ought to be called in question, much less condemned, upon the testimony of biblical passages which may have some different meaning beneath their words. And I think that it's always used to have some little fun when having a talk. So I decided to insert also this picture. So you see this guy here is supposed to be Galileo, inviting a representative of the church to have a look at his telescope in order to realize that the surface of the moon, indicated up here, is not what it was believed until then. But supposedly this member of the church is planning, or I mean, he would like to use the telescope in another way, just to silence Galileo. Of course, the history of the relationship between Galilei and the Catholic Church is more complicated, more nuanced. This picture doesn't really make justice to the historical truth, but I thought it was fun to see it, also because we have to remember that the problems Galilei had have been discussed for centuries, basically until now, in order to advocate for a supposed opposition between science and religion. So let's go back to the definition of science, sense experiences and necessary demonstrations. So what does it mean, sense experiences? It can mean direct experiences, either through our eyes, our hands. This is the meaning of the word sense, but also assisted by instruments. For instance, the telescope was assisting eyesight. Besides direct experiences, there may be experiments. Galilei also performed experiments. And these experiments usually are carefully prepared, always possibly supported by some equipment. And I stress the preparation, which requires some sort of conjecture. So you conjecture somehow what you expect from the experiment, and then you prepare it carefully in order to see whether your conjecture is correct or not. You are putting a question to reality. And these experiments or experiences must be open to sharing, so other people may repeat that, or at least they must be enabled to have a good understanding of what you did. And in this case, measurements can be precious. And also, your experiment must be explainable. This means that you have to give some reason for what you have seen. So you need some theoretical understanding. So there is a sort of circularity, because you prepare experiments already having in mind some sort of possible understanding, and then you modify maybe your theory according to results which were not completely identical to what you expected. The second part, necessary demonstrations, clearly refers to the use of a mathematical framework in this activity, in this theoretical understanding, for instance. And the mathematical framework is essential in order to reliably explain what's happening, and also, I have stressed it, underlying the word, in order to predict something. You see, these physical theories have the ambition of predicting also the future, giving some help in building machines, things like that. So why does it work? Galilei's answer is in the following words, which also refers indirectly to his metaphor of the two books. Galilei had the idea that God wrote two books. Wrote the Bible indirectly, and wrote another book, the universe. And so we have to be able to understand the Bible, and we have to be able to understand the book. But anyway, why does it work? These are again words by Galilei in Il Saggiatore, the Essayer. Philosophy is written in this grand book, the universe, which stands continually open to our gaze. But the book cannot be understood unless one first learns to comprehend the language and read the letters in which it is composed. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one wanders about in a dark labyrinth. So Galilei's statement is very precise. There is this book of nature written in the mathematical language. Either you know mathematics or you are unable to understand. Now, actually, in my opinion, Galilei's answer is rather naive. Today, of course, several centuries later, we are aware that large portions of the universe have not been modeled by mathematics. Think, for instance, of biology. Of course, some people say have not yet been modeled by mathematics. We'll see. And even in physics, there are different and irreducible levels of description of phenomena. Again, some people could say there are still different and irreducible levels of description of phenomena, but in the future, we'll be able to reconcile all theories. You know, there is this idea of a theory of everything that some physicists are after. Now, what do I mean by irreducible levels of description of phenomena? Think of quantum mechanics and general relativity. Those are two physical theories which are at the moment are not reconciled in a unique theory, and both of them are very effective. If you go to a hospital and you have a pet, that's based on quantum mechanics. When you use your GPS, that takes into account general relativity. So we're speaking of theories that do describe certain portions of reality very accurately, also for practical purposes, but still they seem to be two separate worlds. Also, there is another example I put there, hydrodynamics. We have a completely satisfactory mathematical description of hydrodynamics, long since actually, and there is no apparent need of reducing hydrodynamics to quantum mechanics. Anyway, although Galilei's answer is a little naive for the limitations of mathematics which I have illustrated, it is undeniable that the use of mathematics in physics and engineering has led to a spectacular improvement in the living conditions of humanity, or at least we can say of large portions of humanity, but also, luckily, these portions are in progressive expansion. In every part of the planet, governments and people want to take advantage of the benefits afforded by this effective application of mathematics to physics and engineering. Now, the point is that such a spectacular effectiveness of mathematics in physics should be considered surprising. First of all, it is not obvious a priori that some regularities invariant in time and universal in space, what the physicists call laws of nature, must exist in the universe, and much less it is obvious a priori that we can know them. I want to stress, what's a law of nature? It is a regularity which is invariant in time. So it is present today, it was present 100 years ago, it will be present a century from now, and are universal in space. It is present in Ukraine and it is present in South America. So it's not obvious that such regularities must exist, and even if they exist, it's not obvious that we can know them. Maybe there are some we don't know yet. Second, it is something bordering on the mysterious, and this is a quotation I will explain in a minute. It is something bordering on the mysterious that in order to express the regularities we perceive in the world, it is appropriate to resort to mathematics, something produced by our own mind and also something produced with so much effort. So the mathematics we use in science is not so elementary. It requires a lot of effort to be devised. And it's not obvious a priori that such a creation, although a brilliant one, of our mind has to be effective in the study of nature, which it's not our creation. The 2 points made above, including the statement in quotation marks, are taken from the following article, the title of which it is revealing the unreasonable effectiveness of mathematics in the natural sciences. The author is Eugene Wigner, a Nobel laureate in physics. So he thinks that it is inexplicable, the fact that mathematics is so effective. It's a mystery. And Wigner's article has attracted a lot of attention to date, with responses spanning many fields. If you are curious, you can go on the website of Communications in Pure and Applied Mathematics, which is the website where you can download the article, and you can check what is the citing literature list. It's a very long and varied list. So this effectiveness of mathematics is kind of mysterious. And it's not the only mystery involving mathematics, as I will argue a little later. But before delving into that, I want to make a short digression on a challenge brought to the Galilean ideal, sense experiences and necessary demonstrations, challenge brought by some contemporary trends, namely the provocation launched by Chris Anderson in Wired in 2008. The paper has this title, "The End of Theory, the Data Deluge Makes the Scientific Method Obsolete." So the idea is that machine learning methods, which are also involving mathematical sciences, mathematics, statistics, and computer science, machine learning methods can extract true information from the huge amount of data that we can easily amass today without conjecturing mathematical models to be later subjected to experimental verification. So this would render unnecessary the theoretical framework Galilei had in mind. Now, in the stated terms, the idea is flawed for several reasons. For example, statistically, we know that the greater the amount of data, the greater the number of spurious correlations. And there are other convincing arguments against this idea. So it's just a provocation. It's not really a goal. But it's undeniable that machine learning techniques can actually enrich the traditional Galilean schemes because they allow us better mining opportunities. You see, data mining is necessary in scientific activity. You want to extract from masses of data the information you need. And so these learning techniques can be used to some extent for that. There is an interference anyway. Well, I try to keep going. Okay, machine learning is a branch of artificial intelligence, but it's not the only one. And there is another branch, which is an even greater challenge. The idea is that you can create intelligent robots able to operate independently from us, according to the Galilean prescription. So you could replace mathematicians, physicists, computer scientists, and the like with such robots, and they would conjecture a theory, devise experiments, perform them, and eventually improve the theory. So this is much more radical than what machine learning could do. Many people think this is just a dream, but anyway, it is a goal pursued by influential and respected scholars like Julia Pearl. He got the Turing Prize, which is some sort of analog of the Nobel Prize in physics. And he's an expert in causal modeling. So what he is looking for is a way of teaching a robot to reason in the same way we do. So going from cause to effect. So I added this. So this is a robot using a microscope, replacing all of us, perhaps. Anyway, now I go back to the mysteries involving mathematics. I said there was another one besides the effectiveness of mathematics, and I have another statement, kind of long one. I will tell you later the order. Every time you try a framework from within of mathematics, you are faced with invincible difficulties, and in essence, you encounter a certain form of mystery again. Operating as a mathematician, the author is a mathematician, I am led to admit that not only the things that exist are, of course, more than those I know, but that in order to talk about known things, I am forced to refer to unknown and humanly unknowable things. I can never define two areas, one of perfect clarity and one of total darkness. The boundary between the known and knowable and the unknown and unknowable is always uncertain. It is difficult in a short speech to illustrate the mysterious character of the foundations of mathematics, which has been highlighted above all by the most advanced logical research of this century. He is speaking in the 20th century. I will limit myself to noting that in mathematics, even if we want to limit ourselves to finitistic procedures, we must admit rules of a non-finitistic type. In general, the description of certain objects can only be done by admitting rules that are much more complex than the objects to be described. You may have noticed the echo of Gödel's discoveries, which implied that mathematics cannot be reduced to a logical calculation only, and mathematics always transcends the formalization in which it is expressed. In fact, already this morning, Gödel has been mentioned. Gödel has been one of the greatest logicians in history. He was born in 1906 and died in 1978. Now I added another picture. This is sort of a comment to what I said before about the fact that mathematics transcends the logical formalization. You can see mathematics would be the castle up there. It's built on a solid rock, but then if you see here at the bottom, the building is suspended in the air. So this is somehow the condition of mathematics and of all sciences that use mathematics. I comment the picture, which is by Magritte, of course, with this statement by Musil, who was a famous writer, but also trained as an engineer. The mathematicians looked down at the bottom and saw that the whole building is suspended in the air. Yet the machines work. So also Musil refers to the fact that although the foundations of mathematics are mysterious, mathematics does work. It does enable our machines to work. The long statement above is taken from an article that appeared in the Vatican newspaper L'Osservatore Romano in 1979. You can find it reprinted in the book quoted there. The translation from Italian is mine, but in the article related to this talk, I will append the original statement in Italian and also Galilei's statement in Italian, in case any of you know the language and want to have fun reading the original. The author of the statement is Ennio De Giorgi, born in Lecce in 1928 and died in Pisa in 1996. He's one of the leading world mathematicians of the 20th century, mostly known for the solution of the 19th Hilbert problem and the existence of regularity theorem for minimal surfaces. I want to stress that solving one of Hilbert's problems is quite an achievement. You see, Hilbert, this leading mathematician at the beginning of the 20th century, listed a number of problems that were supposed to be the problems of the century. And in fact, most mathematicians did work on the problems posed by him, and solving one of them was rare and considered quite an achievement. De Giorgi got many national and international awards. I remember in particular the Wolf Prize. He was known and appreciated by colleagues of all creeds, I must say, for his commitment to human rights and his religious faith. He was a Roman Catholic. His commitment to human rights was manifest in the 70s and the 80s of last century, when he was organizing international support for some people unjustly imprisoned, say in Soviet Union or in South America. So this aspect of his personality was very well known and appreciated by colleagues of any kind. And I think it's relevant to our conference to stress these two. But in the same article in 1979, Giorgi also makes the following unusual statement. So we have read that he thought some sort of mystery was present in the foundation of mathematics, in the activity of the mathematician, the research mathematician. But now there is a comment on what mystery means. Encountering a form of mystery already in his science, the mathematician cannot be surprised to encounter it again in a much higher reality, such as the religious one. Therefore, the fact that religion foresees the mystery appears to him more as a necessary condition for its credibility than an obstacle to accepting it. It could be said that for a mathematician, a religion without mystery would be obviously false. So mystery somehow, in his view, is a necessary condition for a religion to be credible, because mystery is also present in mathematics. Of course, a necessary condition is not a sufficient condition. And so some mathematicians have not been and are not religious, but many have been and are religious, starting with Galilei already. In any event, this openness to mystery is remarkable. The same mathematics that helped free scientific investigation from undue theological interference is actually a bridge between science and a certain openness to the mystery of reality. And so this is somehow the explanation of the title I gave to the talk, Mathematics as a Bridge between Science and Religion. The last slide is again a picture. In my view, this is the bridge of mathematics seen from the shore of science. So science is here, where the picture is clearer. And then there is this bridge of mathematics going towards the mystery of life, let's say. The bridge does end somewhere. I'm not claiming that it's a bridge suspended in the air. The bridge does get somewhere, but here some clouds, some fog, makes more mysterious where the bridge is leading to. And so this is the end of my talk. Thanks for your attention.